So this is the numeric expression of second law of Newton. This is the numeric expression of second law of Newton, where force applied becomes equal to the product of mass of that body on which the force is applied and the acceleration of the body. Now this expression has some application in real world also. We are now going to see what are the applications of second law of motion, which is F equals to ma. Okay, so this is the general expression, F equals to ma. We have to consider this expression in all the following applications. Application number 1, what is in case of block and string? Okay, in case of block and string, what is happening over here? See, suppose a body is resting on a plane and it is pulled by a force of 100 Newton. Okay, it is pulled by a force of 100 Newton. So this body having mass, suppose 5 kg, you have to find the acceleration in this body. If you apply force of 100 Newton in this body, it will start to accelerate, okay, in this direction, in the direction of application of force, and we will have to find the value of this acceleration. How? See, we know that F equals to ma, so acceleration will be F by m. So acceleration in this case will be 100 by, what is the mass? 5, that means 20. What will be the unit? What will be the unit? You have to remember the units of every physical quantity correctly. Acceleration is having the unit meter per second square. Okay, this is the unit in SI of acceleration, meter per second square. This is a simple example of F equals to ma expression. Now let's complicate it a bit more. There will be a presence of string. Okay, a string which is a rope. In earlier video I have said that string, whenever a body is hanging from a string or pulled by a string, this is a string, this is also a string, it will have another force created which is called tension force, and this tension force will always act away from the point of mass. Okay, this tension force will always act away from the point of mass. See what is happening in this case. Two bodies are kept on this plane and these two bodies are tied with a rope. On a whole, these bodies are pulled by a force of 300 Newton. Let's say the force is 300 Newton. This is a 10 kg mass, this is a 20 kg mass. So let's say this is tied, these two bodies are tied with this string and it is pulled together. It is pulled together by the force of 300 Newton. You have to find the expression of this tension. Okay, so let's apply tension forces. Where will be the application of tension forces? I have said away from the mass, so this, in this string, this will be the tension force, and for this mass this will be also the tension force. And remember, this is, as because this is a single string, the tension will be same. Okay, both are T, not any different expression, both will be T. So here what is actually happening, this force is applied in this direction, so acceleration will be in this direction. Okay, now the force is in the direction of acceleration, so force will be greater. We have to take this positive force, this Newton, as greater. So F and this tension will be in opposite direction, so F minus this tension equals to, we have to follow this equation, F equals to ma. So this is the expression of effective force, which will be equal to the mass of these two, which is m1 and m2. Let's say m1 plus m2 product with acceleration. Okay, this is the general expression which is going to be formed from this system applying second law of Newton. Now what are the quantities we know? F we know, m we know, we don't know two variables over here, tension and acceleration. So how that could be found? From previous example, we know that if acceleration is the value of force, which is 300 Newton, and the total mass. The total mass in this system will be 10 plus 20, which is 30. Okay, 300 by 30. So 10 meter per second square is the acceleration of this entire system. So now we know the value of m1, m2, this force and this acceleration. So T will be easily found out. We have to consider one more thing over here, that to which body the string is applied. Okay, the body through which the force is applied, we have to take that body only in this expression. So this expression will be, in case of this picture, only m2 into a, because the force is applied to the m2 mass. So here force is given as 300. We don't know the expression of tension. m2 is 20, acceleration is 10. So the expression of tension is 100 Newton. But what will happen if we apply force to this object, to m1? In this case, there will be some another value of tension. Okay, there will be some another value of tension. What will happen? Force of same 300 Newton, and the force is now applied to m1. So acceleration will be in this direction. Okay, so force and acceleration having same direction, force will be greater. So F minus T will be m1 into acceleration. So what will be the value? 300 minus T, 10, which is m1 into 10. So tension will be 200 Newton. Here you can see the value of tension force is depending on the body on which the force is applied. Okay, this is a very vital point. The value of tension force will depend on the body which force is applied on. For the second application of the second law of Newton, we have to consider a different system, which is pulley and string. Okay, for the second application of Newton's second law, which is pulley and string, this is the second application. What is happening in this case? There is a pulley tied with the rope from a rigid support, and two or more masses are hanging from the pulley. I am showing you first case, which is two masses are hanging from the pulley. So what will happen in this case? You have to make some assumptions while solving pulley problems. What they are? This string, which is tied around the rope, tied around the pulley, have to be inextensible. मतलब खींचने से वो बढ़ेगा नहीं. Will be massless, and the friction of this region between pulley and the string will be neglected. Negligible friction. All these three assumptions are made while solving pulley problems. Okay, these are assumptions which you have to keep in mind through the entire chapter. So what is happening? There is a mass m1, there is mass m2, and given that m2 is greater than m1, so m2 will start to slide, okay, and the pulley will start to rotate in this direction. So the acceleration of the m1 mass will be in this direction. So what you have to now apply the tension forces, which is away from the string, away from the mass. Tension force of the string will be away from the mass. Okay, I have mentioned that. So you have to now construct the equation for this pulley system, keeping this expression in mind. You have to first consider the expression of force. What are the forces acting over here? And one more thing, Okay, to construct the equation of Pulley system, one more important thing you have to know, which is free body diagram. Free body diagram. All the problems of Pulley are solved by this concept. ये बहुत इंपॉर्टेंट कंसेप्ट है, इसको जितना स्टार तक हो सके मार लो, ठीक है, स्टार जितना स्टार हो सके मार लो. सो फ्री बॉडी डायग्राम, शॉर्ट में इसको हम बोलेंगे FBD. FBD में क्या होता है? फ्री बॉडी डायग्राम में आपको क्या करना पड़ता है? द फोर्सेस विच आर एक्टिंग ऑन ईच ऑफ द बॉडी, you have to express it in a linear manner, in a directional manner. Okay, and you have to consider this body as point mass. Okay, you have to consider this body as point mass. तो पहले हम देख लेते हैं इस बॉडी में क्या कौन कौन से फोर्सेस एक्ट कर रहे हैं. डाउनवर्ड फोर्स है एक M1G, अपवर्ड फोर्स है टेंशन. ओके, and in this body also there is a downward force M2G, upward force tension. So if you draw the free body diagram of M1 mass, I have said you have to consider this mass as point mass. Okay, this is M1 point, and downward which is acting M1G, upward tension. Okay, and the acceleration is in this direction. For M2 downward is M2G, upward is tension, acceleration in this direction. Okay, these two are free body diagrams of these two masses. Now we have to consider the equation of second law. M2G will be positive, upward is tension, this is effective force, and the product of mass which is M2 and acceleration A. For M1, this is for M2. Okay, for M1 it will be acceleration which is in the opposite direction of M1G. M1G या टेंशन जिसके भी opposite direction में acceleration होगा, you have to take that direction as negative. Okay, in the direction of acceleration positive, opposite direction of acceleration negative. In the direction of acceleration यहाँ पे क्या है? टेंशन है. So tension will be positive and negative will be M1G equals to the product of mass which is M1 in this case and acceleration of the system. These two are now the expression for this Pulley system. Okay, so ऐसे और भी कई Pulley's के questions आपको solve करने पड़ेंगे. I have made a video upon this Pulley system. You can check it out. There is a detailed discussion of pulley and string system in that video. From these two expressions, you can find the value of tension as the acceleration. What will be the acceleration of these two system? Acceleration क्या होगा? Acceleration में आपको कैसे निकालना है कि tension from this expression is M1 common G plus A, and tension from this expression is M2 common G minus A, which is tension. So you have to equate these two expressions. You have to equate these two expressions to find out the value of acceleration, and G is given, M1 M2 will be given. So from there you have to just put the values in any of these two equations. You will have the expression or the value of tension. Okay, these were the two applications of second law of Newton.